welcome back. Hector here from helpmegraduate.com. Now we're going to talk about limits regarding trigonometric functions, okay? In my personal opinion and the experience that I have seen from people that I have studied and people that I have taught, limit regarding trigonometric functions, meaning that the function that is being limited is a trigonometric function or involves something with a trigon, are the hardest limits of all, okay? I'm not going to lie to you or be dishonest. They are hard, okay? But there's one good side from it. Number one, they are hard because they deal with a lot of properties regarding trigonometric functions, and some of these properties in theory we should have learned from the past, whether it was from high school or preparing for the SATs or an admission exam in college. In theory, we should know these properties, okay, by the time we get to limit of trigonometric functions. Number two, they are hard because they involve a lot of knowledge of what they refer as notable trigonometric limits, which we're going to see in another video upcoming, okay? And number three, they are hard because they require a lot of creativity regarding 1 and 2, meaning you have to be creative with, number one, the properties of trigonometric functions, and number two, the notable limits of trigonometric functions, okay? That's why pretty much they're hard, okay? You have to have a lot of expertise and practice and knowledge with the properties, with the notable limits, and once you have that, you have to be creative with that, okay? And the first couple of examples that I will bring you in the upcoming video are going to be real easy, but then they're going to be some exercises that are going to be a little bit harder and challenging, you know, especially mine while speaking, okay? The good side of it is that solving limits with trigonometric functions, it really enhances your brain capacity and your creativity. It makes you think as a mathematician because you have to be creative. You have to invent and see what happens if you do this, and see what happens if you can use this with this, and let's say we add this. You see, you experiment a lot of things, and it's not about following a formula or just being a mechanic. It's about solving something with your own brain, and it's a very beautiful thing, and it's a very big achievement once you solve a very hard trigonometric limit, which we're going to do in upcoming videos, okay? So what we're going to do first, before anything, is I'm going to list the most important trigonometric properties that I consider are going to be used in most resolution of the limit, okay? So the first one, as you may have imagined, is the identity property, which states that sin of x, sin square of x, plus cos square of x equals 1, okay? This is the main identity of property of trigonometric functions, and we proved it in a past video where we explained the trigonometric circle, okay? The second one is a consequence, which is sin of x over cos of x equals tangent of x, okay? And by doing this, you know, I can be able to come up with the other ones for the remaining trigonometric functions, which I'm going to do only one time, okay? So this is the second one. Let's do 1. Let's do 2. 3. Cos of x over sin of x equals cotangent of x. 4. 1 over cos of x equals sec of x. And 5. 1 over sin of x equals cosec of x, okay? These are like the main basic ones, and I'm going to separate them like around this, okay? Now, the remaining of the properties I'm just going to do for sin and cos, okay, which are the two most important functions, well, two most important functions, trigonometric functions per se, okay? And the rest of them, you can just deduct them themselves, or you can just look at them at the table exercise in the back of your book, which it probably will be, okay? But I think it's better to just focus on sin and cos, because that's pretty much where we're going to see the exercise is happening, okay? So the sixth property I'm going to write, it's going to be the following. Let's say we have sin of x plus y, which is called the property of sin of an addition of two angles, okay? Sin of x plus y. This is equal to, say, sin of x cos of y plus sin of y cos of x. And you will also see in the textbook and in the properties that it can be either plus or minus, okay? So I'm going to write plus or minus right here. It's only that you have to be consistent, okay? So if it is the addition of two angles, then the result is going to be an addition, okay? If it's the subtraction of two angles, then the result is going to be the minus sign, okay? So they are depending on each other, okay? The seventh one is going to be the same for cos. Cos of x plus or minus y equals, and here there's going to be a slight difference. It's going to be cos of x cos of y minus plus sin of x sin y. And as you can see, there's a slight difference, okay? If it's an addition of the angles, then the property is going to be reflected as a minus. If it's a subtraction, a minus, then it's going to be a plus, okay? You have to correspond with the signs, okay? We will see this in a further exercise. Eighth and ninth properties are referring about the parity of the function. Remember when we talk about parity of functions, whether if a function was pair or non-pair, if it was symmetrical with the y-axis as well. Sin of minus x, it's a non-function, meaning that it's not pair. So this is equal to, say, minus sin x. And 9, cos, on the other hand, cos is a pair function. Cos has symmetry with the y-axis. Remember the chart? Cos of minus x equals cos of x. Okay? And again, remember the graph of sin and cos, and you will be able to understand what's going on here. Okay? 10, and let's change the color so that it looks a little bit more different than blue. Let's do 10. It's going to be, this one is called sin and cos of a double angle, okay? Or a doubled angle. Sin of 2x equals 2 sin of x cos of x, okay? And 11, the one for cos of 2x. So as you can see, we're doing both, right? Just sin and cos, just focusing on those two, okay? Equals cos square of x minus sin square of x, okay? And this little property you can rearrange and rewrite in different ways, because as you can see, you have cos square and sin square, and you can use the identity function to rewrite it back, okay? And one of the ways we can rewrite it is just saying something like, let's see, if we add 1, we have 1 minus 2 sin square of x, okay? And there's another way we can even rewrite it too, and I'll leave that up to you. You can even post it in the comment section, okay? So there we are, 11. I think we can write two more, okay? Let me erase. Where can I erase so that I have enough space? I think I can do it here. Well, maybe I won't have enough space. Let me write it right here at the bottom. Say 12. This is called property of a halved angle. So it's, instead of twice, it's going to be half of it, okay? So sin x half, okay? Instead of twice x, it's x half, okay? This is plus or minus square root of, and as you may have imagined, you know, it kind of makes sense, you know? The double angle has a square, so the half angle should have a, you know, square root. It was kind of predictable. 1 minus cos of x over 2. Okay? And 13, cos of a half angle is going to be equal plus or minus square root 1 plus cos of x over 2. Okay? Again, by this time you're probably saying something like, how am I supposed to memorize all this stuff? Okay? And I think we can even mention another one. Just 2 more. Okay? You're gonna be like, whoa, 2 more? Well, yeah. Okay, just one or 2 more. Okay? 14 sin square x is also equal to, hopefully you can read this, sin square of x, 1 minus cos of 2x over 2. And 15 cos square of x is equal, sorry, again, it kind of makes sense because it's cos in this case, 1 plus cos 2x over 2. Okay, that's it. 15 properties. Okay, I erased the ones that you should already know by now, because these are kind of the ones that you really want to memorize. Okay, so like I said, trigonometric limits are hard because you have to memorize all of this. Okay, and not only you have to memorize, you have to be creative with this and the exercise, and you have to add the fact that there are notable limits, notable trigonometric limits, okay, which are properties of trigonometric limits, okay? So there's a lot of stuff, as you can know, as you can see in the board, and that's what makes the exercises challenging, okay? I'm going to start with a couple of easy exercises, and then we will move on to some that are going to be a little bit harder, and we're going to use some of these properties, okay? It's all about practice, and I'm going to do more exercises on limits regarding trigonometric functions because I know that they're very hard, okay, and challenging. So, good luck. See you in the next video.